For APCalculus, we're looking at some examples of right triangle trig. Directions: find all the missing sides and all the missing angles. Use trig ratios to solve each of the following. So let's look at number 3. First of all, let's put the information onto the picture. We know that AC is 11. We know that CB is 16. So to finish this problem, we have to know what angle A is, angle B is, and we have to know what this side AB is. So let's find AB using the Pythagorean Theorem. Pythagorean Theorem, x squared plus y squared is r squared. I'm going to call x the horizontal side, y the vertical side, and r is the hypotenuse, which is AB. 16 squared is 256. 11 squared is 121. If you sum those, you get 377. To get AB by itself, you square root both sides. Anytime you initiate square rooting, you're going to do plus or minus. In a triangle, in this context, all the sides are going to be positive. So to answer one of the questions, we're supposed to find all the missing measurements. One of the missing measurements is AB. It's square root of 377. One second here. All right. So then let's try to figure out what the measure of angle. Let's say angle B. So which trig function uses the opposite leg and the adjacent leg? Now it's true we could also use this new length that we found, square root of 377. I think it'd be easier to use these integers. So tangent of angle B is the opposite leg over the adjacent leg. Now if you recall from geometry, how do you get this angle B by itself? If you remember, tangent attaches itself to this B. How do you unattach tangent? You have to do tangent inverse to both sides. I'm just going to show a little bit of extra work for this for notes purposes. I'm going to do tangent inverse to both sides of the equation. Could have easily just written this up here, but I wanted to leave that original equation pure. On the left side of the equation, tangent inverse of tangent, they're inverse operations, they cancel out. On the right, we got tangent, and I miswrote this, I'm sorry. This shouldn't say tangent, this should say tangent inverse. I put this tangent inverse on both sides of the equation, and it has to be on the left side. In other words, I could not write tangent inverse here, it makes no sense. If you then put this into your calculator, making sure your calculator is in degree mode, this is going to be about, round to 3 decimal places, 34.508. To get this in degree mode, your calculator, I think you hit the mode button, and then you scroll down, and one of the things says radians or degrees. Put it on degrees, hit enter, then hit second quit. And tangent inverse is on the same button as tangent. You hit second and then tangent. Type in your sides, 11 over 16 is going to give you an angle. All right, so we got one of the angles. That didn't work out very well. We got one of the angles we're missing, and we got one of the sides that we're missing. To find the third angle, let's just use the Angle Sum Theorem. In fact, let's go a little bit easier. In a right triangle, we had this theorem in geometry. In a right triangle, the two acute angles have to be complementary angles. So if we say measure of angle A plus the measure of angle B is 90, and we know the measure of angle B is 34.508 degrees, I should mention that from now on in this class, we need to label these angles as degrees. Because if we don't put a degree symbol, it actually means something else. Hopefully I was disciplined when I did the homework that I did that. If I didn't, then I am a hypocrite And we all know how people feel about hypocrites. Measure of angle A is going to be 55.491 degrees. Directions, find all the missing sides and angles. Now we have all 6 parts. We got the 3 angles, and we got the lengths of 3 sides. Let's look at number 4. Number 4, we are given an angle. 43 degrees is angle A. Side CB is 12.5. Got to find all the other missing parts. Let's find the missing angle first, because that's pretty simple. An elementary geometry student could do this. Measure of angle A plus the measure of angle B have to be 90. The 2 acute angles in a right triangle have to be complementary. So we would find that the measure of angle B is 47 degrees. That's great. We got one of the things done right now. I don't know if I said 43 or 47. It's 47 degrees. Now, to find the other missing sides, specifically, we need to find AC and we need to find AB. We got some options. We could use 43 degrees as an angle, or we could use 47. Doesn't matter which one we use. Let's say we want to use the 43. So we want to use the 43, and we want to figure out what AB is first. Opposite 43 is 12.5. It's the opposite leg. The hypotenuse, what we're trying to find, AB, this is the trig function, sine. Sine of 43 degrees is the opposite leg over the hypotenuse. Now, to get AB by itself, we're going to have to multiply both sides of the equation by AB to break this fraction apart. On the right, the AB's cancel, so now we have AB times sine of 43 degrees equals 12.5. To get AB by itself, we're now going to divide both sides by sine of 43 degrees. So AB is going to be exactly 12.5 over sine of 43 degrees. Put that in your calculator, you will find this is approximately 18.328. Please note, in any triangle, opposite the smallest angle is the smallest side. 47 is bigger than 43, so this side should be bigger than 12.5. If it's not, that's a red flag, you did it wrong. This last side should be bigger than both of those, so it's opposite 90. Now we could use the Pythagorean theorem to finish this out, but it's unwise. It's unwise because we'd be using this rounded number to find our answer. We want to avoid using that rounded number. Just for giggles, to finish this off, let's use the 47 degrees. You know what? I'm sorry. I just wrote this in the wrong place. This is AB, and I wrote it where AC was. Shame on me. Shame, shame, shame. Sorry about that. We need to find AC now. We could use this 43 degrees. It'd be fine. I'm going to use 47 just to show you that we can. And I'm going to try to avoid using the hypotenuse because it's rounded. So what trig function uses both legs? Well, that's tangent. So we could say tangent of our acute angle, 47 degrees, equals the opposite leg over the adjacent leg. Now somebody else could say, well, I'm going to use 43. So tangent of 43 would equal 12.5 over AC. That would be completely fine. To solve this equation, we need to get rid of we need to break apart the AC into 12.5. I'm going to multiply both sides by 12.5. On the left, we get 12.5 times tangent of 47 degrees. On the right, 12.5's cancel and we get AC. Put this in your calculator, you're going to get 13.405 is the length of AC. At this point, we've found all the missing parts. We know what AB is, we know what AC is, and we know the measure of angle B. That concludes the 2 examples of right angle trig. In the next video, We're going to learn how to find the area of an oblique triangle. Oblique meaning doesn't have a right angle in it.